Okay, good morning, everyone. Like I said earlier, my name is Denise Shannon. In today's meetup, we'll be talking about how to manage your Kubernetes clusters, how does HA work, and so forth. I'm joined here today with Alena.
Hello, everyone.
She'll be joining me to go over the Kubernetes side, and then we have a guest speaker afterwards, Damien Metzler from Nuxeo. Damien, do you want to say hi to everyone?
Hi everyone.
Great. Okay, so first things first, this is a meetup. It's not a traditional webinar. So really what we want to do is we want to encourage people to ask questions. I know even though we can't see each other face to face, we want to make it seem as interactive as possible.
Hey, Denise, just really quickly, is there a problem with the PowerPoint? There we go.
Sorry about that, everyone. I see that now. Thank you, Darren. Darren is also joining us. He'll be joining us to help answer questions, or at the end, he'll be going over the roadmap. So, as I just said before, sorry, this is a meetup. We won't be done on time. If you've been to any of our previous meetups, you will know that we will go well over just because of the demo, how we want questions. We welcome lots of questions. If you've never done a GoToWebinar before, there is a little question mark in your GoToWebinar tab where you can ask questions. Myself and Darren will be on to help answer questions either through the chat directly, or if it's appropriate for the demo, then we will make sure to interrupt Alena and ask the questions during the demo. We will be going through this, hopefully, slide set quite quickly, and then start demoing right away so everyone can see what's going on. And, this is a live demo, so just be patient with us. Because it's live, there are things that might go wrong. There might be some technical difficulties, but, we'll always get through it, and there's always questions to be answered. As I said earlier, since it's a meetup and we can't actually see you, most people like to talk about being on the Rancher meetup in Twitter. Whenever you post it, we try to add it in here, so please feel free to post where you are while you're watching us, and we will be able to see you and find you. So here's the agenda today. I will be covering how we handle Kubernetes in Rancher, and then I'll hand it over to Alena. She'll be talking about HA Kubernetes clusters, and then how to demo Kubernetes deployments and upgrades within Rancher. Then Damien will cover over his examples of how they are running containers at Nuxeo with Arken and Rancher, and then finally Darren will follow up with a Rancher update. So a little bit about our products. So one, we have Rancher, one of our main projects, Rancher, which is a management platform for running containers. I'll cover that in a little more detail. It's open source. I think most of you are here because of that. One of our other products that we have is Rancher OS. It's a tiny Linux distribution that we have that's run purely on containers, and it has Docker running as PID1. So a quick overview of Rancher itself. So Rancher is a way to be able to manage all your containers that you have. We have the ability to have different hosts, what we call hosts, which are Linux boxes across the different clouds. And then you can isolate those resources into different environments, which then you can decide how you want to deploy your containers onto it. We currently support a couple different orchestration distributions or container managements. So we have our internal one, Cattle. We have Kubernetes, which is the focus of today's meetup. We have Mesos, and we also have Swarm itself. And then on top of that, one of the cool features I think we have in Rancher is our Rancher catalog. And so for each of our container orchestrations, there are different templates that are out there that allow you to be able to quickly spin up applications that someone else has already set up, so you don't have to go through that pain of trying to figure out how to set it up, and you can get it up and running and start testing it itself. Rancher has right now over 1 million downloads. We released 1.0 in March. We're currently, our most stable release is 1.1.3, so if you're new and haven't downloaded that, recommend that one. It's open source, there's multi-tenancy, and then, if any of you out there are going to run this in production and you need enterprise support, please let us know. We do offer that kind of support as well. I'm going to turn it over to Alena now, who will be starting her presentation about managing Kubernetes.
Thank you, Denise. Is it good now? Here we go. Hello, everyone. My name is Alena, and as Denise mentioned, please feel free to fire up any questions while I'm presenting, and I'll be happy to answer them. So managing Kubernetes clusters in Rancher. Kubernetes is an open source orchestration platform to manage the orchestration for the containers. It was first started by Google, but there's like a lot of external contributions to it. The latest version of Kubernetes is 1.3, and it was the first project contributed to the CNCF. I've been honored to be a part of the team working on the Rancher Kubernetes integration. It's been very interesting to get familiar with the Kubernetes orchestration and integrate it with Rancher. Now, what Rancher brings to Kubernetes? We wanted to make the user experience better, and we wanted to make it easy to manage Kubernetes cluster and Kubernetes applications. So in terms of managing Kubernetes cluster, the Rancher brings access control management. So we have something called environment in Rancher. Environment helps you to isolate resources and provide the access control to the resources. So Kubernetes cluster is a part of the environment, and you can define who can access the environment, and we support multiple access control types: Active Directory, Azure Active Directory, GitHub, localauth, Open LDAP. So in this picture, there are two environments, one general, another QA. Each one is a Kubernetes cluster. And as you see, for the general environment, organization Rancher can access it. For QA, 2 people can access it. One with an owner role, another one with a restricted. Now, how does it look in Rancher UI? So here's the environments, and let's add a new environment. Add an environment, Alena. And I want to enable Kubernetes and orchestration here. I've chosen the GitHub auth here, and I'm going to invite one of my peers to the project. And I'm going to give her a member role, which is the default. Now I click Create. It creates an environment, Alena, with a Kubernetes orchestration, but we haven't started orchestrating the Kubernetes cluster because there are no hosts in the environment yet. So here we come to adding our first host to the environment. As you can see, we support various cloud providers. I'm going to pick the DigitalOcean. I'm going to provide an access token. And for Kubernetes, we do support single host setup, but we suggest that you add 3 or more hosts because we do the etcd, HA, and for etcd cluster, it's advisable to have 3 or more hosts. I'm going to provision 4 hosts in the San Francisco area. It takes some time to provision the hosts, and then the Kubernetes system stack will get created, and the Kubernetes system stack services are going to be started. So as it takes a while, let's switch to another environment. All right. And this environment already has 3 hosts, but I don't have Kubernetes enabled on it yet. So you can enable the different orchestration on pre-existing environment. For that, click on Edit, go to Kubernetes, click on Save. All right, orchestration, Kubernetes cluster. So Kubernetes system stack consists of several services. Some of them are Kubernetes specific, like I've marked them as blue services on this picture. It's like Kubernetes API server, controller manager, scheduler. As you can see, the kubelet and proxy are started on every host. And then there are yellow services, which is a rancher specific services that we start as a part of Kubernetes system stack. I'm gonna go over them using more details a bit later, but there is a rancher ingress controller, Kubernetes agent, and etcd cluster. So in the UI, you can see the system stacks on the Kubernetes system stacks. You can see the view as the Kubernetes cluster is coming up.
Alena, I'm just going to interrupt you real quick.
Of course.
We've got a question here where it says, when you set up the Kubernetes environment, where do the Kubernetes services live? The rancher system host or the Kubernetes kubelet host?
It's basically two. Like it lives on the rancher system host, which become the Kubernetes hosts. We are gonna in the future we're gonna let dedicate a specific set of hosts just for Kubernetes system services.
That sounds great. Graham, if you have any more questions about it, please let me know.
Hi, this is Darren. Let me just clarify one thing. So so there's kind of the rancher server control plane, but that's running on a separate set of servers than where you have your nodes for your environment. So like when we go and deploy Kubernetes, the Kubernetes, like the controller manager and scheduler and API server, they'll run within the nodes in the environment. So they're not on the same server as where the rancher server is. And we do mix it currently right now with where the kubelets are running. But as Alena said, hopefully soon in our next release, we'll give the ability that you can, when you go to deploy Kubernetes, you can schedule where those components will land. So you can dedicate certain hosts to running etcd and the API server, and then certain hosts as being the nodes.
Any more questions?
Not right now, but I will let you know if there are more.
All right, let's look at the Kubernetes system stack through the UI. You can see the graph view for that. So you can see all the services and the number of containers per every service. You can also check the templates that we used for launching the Kubernetes system cluster. Like you can see, for example, for controller manager, you can see what parameters do we pass to start it. Those are Kubernetes-specific parameters. Luckily, Kubernetes allows you to parameterize a lot of things, and that's the parameters that we are using.
I did get a follow-up question about that, and so Graham asked a follow-up question of, if I keep on scaling my kubelet plane, does the Kubernetes services keep scaling with it, or do they live on a max of 3 hosts?
No, they keep on scaling. So we start a new kubelet and new proxy on every new host that joins the Kubernetes environment.
Well, let me. So I mean, there's multiple parts of the Kubernetes stack. There's the kubelet, which as you add more hosts, we automatically deploy the kubelet. But the kind of the control plane portions of Kubernetes is basically right now a fixed scale of, depending on the component, like etcd is, what is it? It goes up to 3 to 5 nodes. And then the API server and controller master, those we run like either 1 or 2. So if you have like 15 nodes in your cluster, you're not going to end up with 15 API servers.
Right. So as I mentioned earlier, there's pure Kubernetes services like controller manager and kubelet and Kubernetes and proxy, and there are rancher servers. One of them is kubectld, like wrapper around the kube control client, and then we have an Ingress controller. Ingress controller is responsible for creating the Ingress resources in rancher, like for Kubernetes Ingress, we create a load balancer in rancher. And then we have a rancher Kubernetes agent that listens for various Kubernetes and rancher events, and it does some labels provisioning for the containers that started via Kubernetes and then discovered by rancher. As you also see, there is a one more stack that got created, which is a Kubernetes Ingress LB. This is the system stack where load balancers backing up the Kubernetes Ingress are going to. All right, just 1 second, refreshing. Okay, so besides Kubernetes system stack, there are other planes like services, replication controllers, and pods. If you go to this tabs, you can create a Kubernetes specific resources. And the kubectl provides the kubectl client, so you can create your Kubernetes resources using the command line. You can either do it from the UI, or you can do it locally by downloading this config. So orchestration and access control. What else does Rancher provide? We also provide an HA. So in Rancher, you can configure the health check for various Kubernetes services, and then we monitor this health check. We do the probing, and if something fails, we do recovery. And for etcd, we do some extra. So etcd does some data recovery, and if one of the etcd, so the data is being replicated to the up to 3 or 5 nodes, as Darren mentioned, and if something goes wrong, we do the data recovery. So let's switch to the DigitalOcean setup, the one I've just created. Hopefully it's up and running. So as you can see, the etcd resides on the last 3 nodes. So what I'm going to do, I'm going to bring down one of these nodes, and we're going to make sure that all the data is preserved and the etcd gets restored and recovers. So, but first, let's create something. Let's create some data. So I'm going to create an Nginx service using the UI. Right. So it's not ready yet.
While we wait, there's a quick question of, are you moving from replication controllers to deployments, and when could we expect that?
Yes, we are moving to, we're actually going to support both. We're going to support replication controller, replica sets, and deployments. We're going to support in the next version of the Kubernetes 1.3. I'm going to demo it actually today. I'm going to demo the upgrade from the existing Kubernetes version, which is 1.2.4, to 1.3.
So, so right now in the Rancher stable release, which is Rancher 1.1, we have Kubernetes 1.2, and then in our development release of Rancher, which is Rancher 1.2, has Kubernetes 1.3. And so Kubernetes 1.3 is where we've, if you're running Kubernetes 1.3, the UI will show replica sets, deployments, and then also some of the catalog stuff. Hopefully Alena will show.
Okay. Yeah, one quick thing about 1.2.0, the pre-releases, is that when you launch Kubernetes, you'll actually start with Kubernetes 1.2.4, and then you have the ability to upgrade to 1.3, which I think Alena will be demoing later.
Yeah. Okay. So here we have the Nginx service with the underlying pod and the container that is up and running. So, and I'm going to bring down the Alena 2 host from the DigitalOcean. I'm just going to power it off.
Someone wants to know if the Nginx pod you just created is accessible from outside the cluster.
So this is actually the cluster. This is a cluster IP service. So it's not like the node port service. So it's not accessible. Turn off. All right.
It just depends on how you. Sorry, I was just going to say it just depends on how you deploy the service. So Alena had done something just deployed something that was local to the cluster. Yeah. But if you had done a load balance service or a node port, then it would be publicly accessible.
As long as I can access the host. It takes time for Rancher to discover that the host went down. Okay, but as it's going, you can see that the health check most likely got failed for these containers. So then, okay, just to talk about the health check. So we configure the health check for the various services. And if you go from the system stack and do the config view again, view config. you can see that there's a health check description in the rancher compose. Here we define the number of probes that we do and the interval between these probes. And the health checkers for the containers running on Alena 2 hosts are configured on Alena 1, Alena 3, and Alena 4. So, and when Alena 2 goes down and health check is failing, these containers are going to be recreated on another hosts. Which is not happening by some reason. City systems tags. Yes, okay. So the etcd2 is being recreated along with the data container. Okay, here we go. They got recreated on the Alena 1 host. And if you go and check our Kubernetes data, like services and replication controllers, they should stay intact. Okay, we still see our Nginx service, and we still see our Nginx replication controller and the pod. So just to emphasize that, like, we suggest that you have 3 or more hosts for reliable etcd clusters. In this case, like when 1 host goes down or 2 hosts go down, the etcd is still functional. Like the etcd quorum is 2, so it is as long as the 2 etcd containers are up and running, we are fine, and the data is being replicated and stored. If by any chance your entire environment goes down, there is still a way to restore your etcd, so your data, when one of the hosts comes back up. I've attached the link to the document describing how to do it to the presentation, so you can look at it.
I have a couple questions. I know earlier someone was asking about the pod and whether it's accessible outside the cluster.
Mm-hmm.
And so someone else asked a follow-up question of what's the way to expose applications to the public?
Yeah, there are several ways. One of the ways to use the node port service. In this case, the port gets published to the host. The other way is to use the load balancer service. In this case, the rancher cloud provider will create the load balancer on the rancher side, and this load balancer is going to back up your Kubernetes load balancer service, and it will provide the entry point to your application. And the third way is you can use the Ingress resource of the Kubernetes, which is pretty similar to the load balancer. The only one difference, you can define the hostname routing rules for your Ingress resource. I'm actually going to demo the Ingress resource a bit later, so you can see how you can access your application from the outside.
And then one other question was, I think as we're covering HA, is if for some reason Rancher isn't accessible, are we still able to manage the cluster through kubectl, and will those changes reflect on Rancher?
Darren, I think we can still manage, right? The kubectl should still be accessible if it's deployed on the local machine.
Yeah, so basically, it will, if Rancher is, there's various different things here. So basically, if Rancher goes down, all your services on Kubernetes will still work. But obviously, if you do something like change the load balancer and Rancher is providing the load balancing, that won't work until Rancher is back up. If Rancher goes down, it depends on what aspect went down, because we do also provide authorization for kubectl if you're external. So, if that component goes down, then you're not going to be able to talk to the Kubernetes cluster because we can't proxy the API request and authenticate it. So in general, it's kind of the approach that we take is we expect the reliability of Rancher to be such that if Rancher goes down, provisioning will stop, but anything that's running won't be impacted. So it is kind of important that Rancher is up and Kubernetes is up to continue provisioning properly.
Any more questions, Denise?
No, not currently about Kubernetes stuff, so proceed.
Okay. So access control, orchestration, HA, and there is one more key piece into the Kubernetes system cluster orchestration, which is upgrades. So how Rancher deploys the Kubernetes system stack? We have something called Rancher System Catalog that Denise mentioned on one of her previous slides. In the Rancher System Catalog, we store the templates for system services such as Kubernetes, Route 53. And you can upload templates of different versions to the catalog, and you can mark one of them as a default template. So in the picture, the Kubernetes cluster has a is deployed from the default template, which is a Kubernetes 1.2.4 version, the stable version of Kubernetes. But once the new template gets uploaded to the system catalog, which is like Kubernetes 1.3 on the picture, it becomes available and for the upgrades for the existing Kubernetes clusters, and you can upgrade to it. And the UI will prompt it to you. So let's go to the default environment again. All right, so this is our tab. As you see, services, replication controllers, pods. Those are the controls available for 1.2.4. Let's go to system stacks. So here you can see upgrade available. Once you click on it, it prompts you to upgrade Kubernetes system stack. You can choose a version you want to upgrade to. So there's only one extra version as of now, which is Rancher 1.3.0. So we're going to choose it. Here you can preview the changes. So you can see that the image got changed. Now it uses Rancher Kubernetes 1.3.0, Rancher 3. This version correlates to the Kubernetes version 1.3.0. All right, let's upgrade to it. Okay, you can see that the Kubernetes stack is going through the upgrade. First, the Kubernetes API server is getting upgraded as it's the control piece, which other components refer to. Then all the rest is being upgraded. Just to mention, like, why the upgrade is going, all the data, like all the replication controllers, services, pod that you've created, are going to be going to exist even after the upgrade. The data will be intact. Okay, it still shows upgrade in progress, although...
While that's in progress, I have someone who has asked, are Kubernetes network policies supported? I understand that Rancher implements the networking between Kubernetes nodes.
Yeah, so in 1.2.4, we had Rancher networking, which was kind of embedded in the Kubernetes code base. But in 1.3, we are working on adding the CNI plugins, like to support all the various plugins that Kubernetes supports, such as Calico, Weave. And Rancher is going to become one of the CNI plugins. And you'll be given a choice which plugin you want to use for your Kubernetes deployment.
And so currently the implementation of Rancher does not, so when we release 1.2, Rancher networking will be a CNI plugin, but it doesn't respect the network policies right now, but you could switch over to something like Calico that will respect them.
Okay. Any questions?
There are a bunch, but I have not yet screened them yet, so I will let you know as soon as I can.
So you can see that the upgrade has been finished. You can just click on Finish Upgrade. Some cleanup. There you go. And now we can see for 1.3, as Darren mentioned earlier, we have much more stuff in the UI. Now we have the replica sets, replication controllers, pods. And we also have something called stacks, which is not a Kubernetes concept per se, it's a Rancher concept. And what is that? So you can create Kubernetes resources various ways in Rancher. You can either do it by just specifying your template file through the UI, or let's create something. Let's create an Nginx service. Or you can do the same through the kube control. Like you can create your template here and use kube control for launching the resources. And you can also deploy stuff from the application catalog. So we have a system catalog for storing the templates for the system services such as Kubernetes and Route 53. And we also have an application catalog for every orchestration platform. So here's the Kubernetes catalog. It has several templates, and I'm going to choose the WordPress. So see, you can read the description of the template. You can provide a certain configuration parameters, and you can also pick the template version. There we go. Let's launch it. So, and it appears under stacks. Stacks in Rancher allows you to group Kubernetes resources based on the catalog item it was deployed from. It is very convenient because you can actually see which services correlate to which replication controllers and pods, so you can see your application as a whole. And as of now, the application is up to date, but once new WordPress template is uploaded to the application catalog, you can update your entire app to the latest version.
I'm going to pause real quick. So
Sure.
After you did your upgrade from 124 to 130, there are a lot of questions that came in.
Mm-hmm.
So let's try and answer a couple of those. So one of them is, I think you might have covered it earlier, but is there any way to choose a selection of hosts in which to deploy, I guess, the Kubernetes containers that we launched to?
Not now, but we are planning to add it. So you can actually aggregate your etcd. For example, you can aggregate your etcd services on one set of hosts and other services on another set of hosts. We're going to support it.
Another question came in about what happens to stateless apps during kubelet upgrades? Will they be restarted?
Yeah, there's actually an issue on the Kubernetes side. Like when you upgrade from 1.2 to 1.3, all the pods are getting restarted.
Okay. And then during the Kubernetes upgrade.
So I was for a major upgrade from 1.2 to 1.3, they all get restarted. For a minor upgrade, I'm not sure. Alena, do you know if you do a minor upgrade, if the kubelet will restart all the pods?
I'm not sure about that. Most likely, yes.
Okay.
And then, is there any service interruption during the Kubernetes upgrade process, or are the control layer pods the only pods that get recycled?
But the pods getting recycled actually might introduce some downtime for the service accessibility.
Yeah. So so this is like a larger topic within the Kubernetes community right now of, more seamless upgrades in Kubernetes. So right now, an upgrade of Kubernetes is fairly impactful. So you should be, kind of scheduling some downtime if you're going to be doing that, in a maintenance window. I mean, it's not anything particularly that Rancher is doing. We can definitely do like rolling upgrades and make sure all the services are available. But there are some kind of just issues in the upgrade of Kubernetes itself.
So one of the other questions is if we upgrade etcd as well, or just Kubernetes pieces only. So maybe I think it would be good to describe kind of how we decide when to push out new templates to be able to upgrade for Kubernetes.
So it can be either caused by the Kubernetes release. So in this case, it's going to be a Kubernetes specific services upgrade only. So basically, if in your system template only Kubernetes services get changed, then other services won't get upgraded. Like etcd would remain. Would still point to the previous version. But there are also cases when we make changes to our etcd service template. In this case, the Kubernetes specific services will be left on the previous version, and etcd will be using the latest version. But even in this case, like etcd data will remain intact.
Yeah, so I just wanted to point out, yes, we do upgrade etcd. It's honestly like 99% of the difficulty of upgrading Kubernetes. So our engineering team has spent a lot of time on trying to upgrade etcd, getting that working.
And then I know there's someone who's asked if Kubernetes 1.3 with Rancher can run on Docker 112.1.
I believe we evaluated 1.11, right, Darren?
Yeah, so this gets into a kind of a iffy thing. So I know for like our supported customers, we tell them Docker 1.10 because that's really what upstream Kubernetes is telling people too, that they've kind of stabilized on 1.10. We have validated that 1.11 is working, and honestly, there's no with the exception of swarm mode, there's actually not like a fundamental difference between 11 and 12. So we do expect it actually to work on, sorry, on Docker 1.12. But so it's like your mileage may vary. Kubernetes upstream is saying 1.10. It's the best route. And for Rancher, we support back to Docker 1.10.
That's great. And then to go back to kind of where we were in terms of adding stacks from the catalog, there is someone out there who asked about if you can add your own templates to a catalog. So I don't know if you want to, I mean, I can demo or you can show how you can create your own private catalogs and then add them.
You can go ahead and demo it.
Okay.
Okay, should I switch to?
No, I'll just use.
You want to do it now?
Yeah,
Okay,
I'll just show you that.
Sure.
So within Rancher, you can easily add your own catalogs. If you're an admin under settings, you can add your own catalogs here. You can define your own catalogs in GitHub. There's some documentation out there on how you create your own private catalogs. The way our catalog service works in terms of reading which templates to use for which environment type has some setup that is out there, and it's in our docs. I'll share the link out there. But once you can add it, you can add your own catalog here, and then it will automatically get shown up.
And we added this cool feature branches that you can
Oh, yeah.
which branch of your catalog you can use.
Yep. So we just introduced branch support for your catalog as well, and so you can. Once you add your catalog here, you can see when you have more than one catalog, you can actually search between the catalogs of which catalog you want to show in terms of inside your catalog service here.
And you can also add your template to the Rancher community catalog. We appreciate any contributions. Great. Any more questions? Or should I?
No, I think you should continue.
Okay. So besides everything that was covered, there are a couple of features that I want to go over. The features that we do for Kubernetes. So one is the Rancher integration with the Rancher private registries. So you can specify your private registry in Rancher. It can be either Docker Hub, QA, or any custom registry of your choice. And then this custom registry can be used for when you deploy your Kubernetes applications. So for that, we had to write our plugin, like credential plugin for Kubernetes. It was relatively easy, and it is working. So the other feature that somebody asked about is like Ingress feature that allows you to provide the entry point for your applications. I'm gonna demo it. So now we have an Nginx service, and I'm going to create an Ingress resource that allows you to access this Nginx service. Here's the description. It's going to be a very simple one. It doesn't have any hostname routing rules now. And unfortunately, we don't have a UI for that yet, but we're going to add it in the future. So I'm going to do it from the kube control. I'm going to create the Ingress resource. Okay, so it's not ready yet. So if you go to the systems tags, and if you look at the Kubernetes Ingress, you can see that we are creating the Rancher load balancer that will back up your Kubernetes Ingress resource. We can look at its details. So here, it has a source port and it has a target port. And it will have a hostname routing rules once we add it. If you go back to the kube control, so you can see that the Ingress's address was populated. So this is the IP address of the host where Rancher load balancer backing up the Ingress resides. Now we're gonna try to access it. Here we go. Now we have the Nginx. Now, if you want to create a hostname routing rules for your Ingress, you can do it like by modifying the Ingress resource. So here you can see that only the requests for hostname foobar.com should be forwarded to the Nginx service, nothing else. So let's modify our Ingress resource. You can also do it from the kube control. I just removed that old file. Okay. This will modify the existing load balancer resource. So if you go to the system stacks and Kubernetes Ingress, let's look at it and see if it has hosting routing right. Oops, somehow it doesn't. Something went wrong. Replace. Okay, I used the wrong command. Should have called replace. Okay, so it looks like it was replaced, and now you can see service unavailable because we haven't provided the correct hostname routing rule. But now let's go to the system stacks, Ingress LB, edit, and now you can see that the request host was changed for the backend server. And only when you access this service with a correct host, you're gonna get forwarded to the, let's do it. No, incorrect host. All right, so now we got our Nginx host because we specified the correct hostname routing rule. Now you get the service unavailable if you specify the invalid one. We do the load balancer service support in Kubernetes similar way, minus hostname routing rules. For every load balancer service created in Kubernetes, we are creating the load balancer resource in Rancher. And its load balancer resource in Rancher currently is backed up by HA proxy, but we are working on adding more provider support like Nginx, Traffic, and you'll be able to specify like which provider you want in the future when you create your Ingress resource or load balancer resource. And then I want to talk a little bit more about our future plans. Like currently we officially support 1.2.4 and 1.3 version of Kubernetes. 1.2.4 is the default one. For 1.3 we had to make some modifications, like the 1.3 introduced a stateful application support in Kubernetes called PetSet. We had to do some extra work to add a support for it. And for 1.4, our plans is to contribute the Rancher provider code to the Kubernetes. Like as of now, we maintain our own fork of Kubernetes because our networking changes were embedded into the Kubernetes code. But as we move them to the CNI plugin, that plus some extra work we have to do for volumes will actually allow us to completely separate our code, so it will be good for contributing it back to Kubernetes.
One quick question has been someone wanted to see if you could do a kube control of get services just to show what it shows up.
Sure. It gives you the list of the services. Any particular?
Nope, that was just a question.
Oh. You can execute any kube control command, anything that Kubernetes supports. You can list the nodes, which will be all the hosts that we registered. And you can see their statuses. Like if something goes, like if the node goes down on the Rancher side, it's going to be automatically excluded from the list of nodes on Kubernetes.
Someone asked if there was an edge node, so are the services exposed by the Ingress exposed on every node in the cluster?
It actually depends. Like we start just one load balancer, but you can configure it. Like you can scale it up. Like you can scale your Ingress resource, and you can define the scale in the Ingress config file. In this case, we're going to create 2 load balancers in Rancher, and when you do get Ingress, instead of seeing just one IP address here, you will see the 2 IP addresses of 2 of the hosts where a load balancer is deployed.
The person who wanted us to look at the kube control get services wanted to know why is it showing pending for external IP?
For the just for this that I'm not sure. I suspect that it's because of maybe this IP address ports is already being allocated by the Nginx service. That's probably the reason. Or maybe like if you see it on your setup for some other use case, it can be some bug. Most likely it's because of this port clashes.
There's also another question about, there's been a couple of questions mostly about persistent storage and what happens about stateful services. When a node dies, what happens?
So about the storage, so we support the persistent volumes, like whatever Kubernetes support, we do support. And stateful services, is it like a pet set or?
Well, I mean, so basically, I mean, we support what Kubernetes does. So stateful services are basically done primarily through persistent volumes. So persistent volumes and persistent volume claims. So in those situations, you often rely on some type of external storage. So it's like EBS or Google storage or NFS, something like that. So when the node goes down, then they can reschedule the pod somewhere else and then use the same storage.
Those are all the questions I have for now.
And I think that's all I have.
Okay, that sounds great. If anyone out there still has questions about Kubernetes, we'll still be online. We can respond through the chat. I'm going to now, I know we're also approaching the 1 hour limit, and I just want everyone to know that we are recording this meetup, so if you have to run to another meeting, we will be posting it up on YouTube a couple days after the meetup is over. If you missed the first half, you can see that as well. So I just wanted everyone to know. I'm going to now switch it over to Damien.
Hello. So let's check that.
Just to let you know, Damien, I still don't see your screen.
Okay.
Started.
You can see it?
Still see my screen?
No, I don't. I do not see your screen yet.
Okay. Is that okay now?
Yep, I see your screen now.
Okay.
That sounds great. Oh, and now I don't see your screen anymore.
Yeah. It's when I go into main screen. When I go in full text, it doesn't work. Sorry. So let's keep it like that. So good morning or good evening for people. My name is Damien Metzler, and I work working for a company called Nuxeo.
Damien, I apologize. I still don't see your screen.
Oh. So, like that, is it okay?
Nope. If you want, I can. I still don't see your screen.
Yeah.
Oh, I see it now.
Okay, good. We'll keep like that and don't touch anything.
That sounds great.
Okay. So where was I? I'm working for a company that's called Nuxeo, which basically we develop a platform. We develop the technical component for a platform, meaning the assemblies, the packaging tools, the testing tools, for a development platform that is open source, like Rancher. It runs on Java. The cornerstone of our platform is a content repository that allows you to store, manage, index complex objects. And the global ID is to let our customer configure their domain model and let Nuxeo handle all the storage problems, the security problems, and things like that. And it also exposes some higher level services like notifications, conversion services, audit trays on documents, and workflows. Basically, our main objects are documents. So, what's the challenge? Historically, we sell our platform to a customer who installs Nuxeo as an on-premise platform. So they have big servers for just one user. They don't have any problem. We help them to customize their software, and that's good. But nowadays, we are facing new problems, like having thousands of users, and we want to help those users to handle their applications. So, long story short, in 2013, we decided to use Docker to encapsulate our application, and we were facing some problems with Docker, meaning that in Docker you can run any container, but the port of your container is randomly chosen, and you can run your container on several hosts, and giving DNS address like Docker has 2-49-209 is not an option when you want to deal with meaningful addresses. So what our user wanted is to be able to address their container with meaningful addresses. So that was our first problem. Our second problem is that we decided to use that type of solution to handle our trial instances. When you go to Nuxeo, you can subscribe for a trial period of 30 days, and you want to try Nuxeo, meaning you want a live instance of Nuxeo running. And if you dedicate a single VM for each customer, you will end up throwing all your money into Amazon, which is not exactly what we want to do. So we decided to find other solutions. We will talk of that a bit later. So our first problem is, how can I route my customer through with a regular and meaningful DNS address to my container? So we decided to create our own reverse proxy, which is called GoGeta. Basically, the architecture relies on a shared registry, which is etcd, like Kubernetes, which holds the states of our services. Using a shared registry allows you to share the state between all the hosts of your cluster. And that's exactly what we do here. So basically, when a user comes to mydomain.nuxeo.io, he ends up on a regular load balancer like ELB, for instance, which spreads the request across all our servers in the cluster. So GoGeta listens to all those requests. He reads into etcd the value for that domain. So for instance, my domain.nuxeo.io here goes to the service that is called NXIO 0098. And in the services hierarchy of etcd, we have the location of that services, which goes back to GoGeta, and GoGeta now can proxy the request to the right container, even if it's not on the same host. So the idea of that is that it's completely dynamic, meaning you can update the location of a host at runtime. GoGeta won't have to restart and update its configuration. It's just live. It just uses etcd to get updates on host locations. So that's how we solved the routing problem that we had. The other problem is to don't spend all his money into AWS. So for trials instance, one thing that you may notice is that when you try a software online, you often try it for 10 minutes, 30 minutes, perhaps 1 hour if the product is awesome. But after 1 hour, you put it away and you look at other products and you try other ones, and then you come back to 2 hours. But during that time, your application is not used, but it consumes resources like CPU and RAM. So we needed a system that allows us to spare those resources. So as we have in our infrastructure a reverse proxy, GoGeta in fact just traces the last time a container has been accessed. And we have a service called the passivator in our infrastructure that checks every 5 minutes that every service is live and has been used in the last 12 hours. If a live service hasn't been used for the last 12 hours, then it is passivated, meaning we stop, we kill the container, we keep the data outside, of course, and we put the status of that container to passivated. When our user come back to mydomain.nuxeo.io, GoGeta sees that the service has been passivated, and it asks the passivator to restart the service. So it will give the user a page that says him, just wait, I'm restarting the service because it has been passivated. We'll see a demo of that later. So the global architecture of Arcan is quite simple. We have a central library that's called GoArken that handles all the logic of services, of domain and things like that. We have the Arken daemon that exposes a REST API on top of that. We have GoGeta that uses GoArken to update its state, and the passivator that also use it. And all data are backed into etcd. And then the GoArken library has a CAS adapter, which now plugs to Rancher, that can drive Swarm or Kubernetes. That piece is changeable, so we plan to plug directly to Swarm. And theoretically, it still works with CoreOS and Fleet, which was our first implementation, but it's pure theory. So all the Arcan infrastructure runs itself into Rancher. So let's see how it works. So here I'm in Rancher. As you can see, I have an Arcan stack, which an etcd node, a GoGeta node, and an Arcan node. In fact, in our last versions, the passivator is embedded into the Arcan daemon. So this is just a regular Arcan stack, and we have an Arcan catalog here. It's very easy to start that stack here. Okay. The only configuration option you have is to give an API key to the Rancher server, because Arcan uses the Rancher API to drive its services. So having that stack, now you can access the Arcan API here, which has a documentation on its API. And we can try to create a service. So let's use just the sample parameters. So here I would create a stack that is called nxio-00001, and it will handle the test.devio domain name. And it will use the community Nuxeo 0 template of Rancher. So let's try that. So it says OK, and now in Rancher you can see that I have a new NXIO stack, which just used the Nuxeo template, which is in the community catalog of Rancher. Now I will be able to start my application using a boot address. So let's say, let's start it. And when I start my application here in Rancher, I can see that the state is updated and that my stack is activating. So now I should be able to access test.devio and see that Gogeta gives me a screen that says, hey, your application is starting. So it's not ready yet, but it will work. So the implementation and detail of that is that I've set up my DNS so that with a catch-all address, so that star.devio points to my Rancher stack. So if I use non-existent .devio, HTTP, .devio, Gogeta gives me a 404 page saying, what are you looking for? This page doesn't exist. So now my application has started on test.devio here, and I can log in into Nuxeo. Of course, it will work. So with that, we have dynamic routing, meaning that I can very easily add new Nuxeo instance and serve new customers with all their parameters and things like that. So let's try to create another stack, but which uses the passivation, because we can set up the passivation time, which is by default 12 hours. But here I will say that the passivation will work for, let's say, 20 seconds. So let's create my stack. I can see here in Rancher, why doesn't it work? Of course, let's put 20, not in quotes. And now in Rancher, I should have my sleep Rancher here that we start. And now my stack will start. So it's a different stack using what we call our Nuxeo trial stack, which embeds all the database, the Elasticsearch index, and things like that. It should be faster to start. And I can go to sleep rancher.dev.io. I didn't remember the. Oh, I called it sleep.dev.io. So when I go to sleep.dev.io, HTTP, one more time, I can access my new app. This is a different instance. And if I wait for 20 seconds after my application has been accessed, it should be passivated. So we see here the sleep rancher in 20 seconds should be passivated. Sounds out loud. Just a matter of waiting a bit. So let's try the demo guards. Now perhaps some Ajax things. Okay, let's see. So after a few seconds, my application here is passivated, meaning it is stopped. And when I want to access http sleep.dev.io, the application says your application has been sleeping, waking it up now, and it sends a start command to my rancher stack. So that is passivation. So coming back to my slides, the Arcan API is just a higher level API on top of Rancher that relies on Rancher stacks, meaning that it should also work with Kubernetes stacks. And we feature services. We have a basic CRUD operation on services, and there are tons of options you can pass to services. For instance, about the passivation, you can say that instead of my service to be just passivated, I want it to be destroyed, and you can pass, you can enable or disable passivation, thing like that, and that's it for me. If you want some resource, I've written a blog post about how we use the Rancher API with Arken. We can find you can find all the resource on GitHub for Nuxeo, and we have a dedicated repository for Arken, which is called Arcan.io, on which we will find the source code of Gogeta and Arken, which are both coded in with the Go language. That's it.
Thank you so much, Damien. That was great. I think it's always exciting to see how users are using Rancher in real-world applications. I'm going to now take over the presentation. Share my screen, and then I'm going to have Darren come join us to talk about what are the upcoming or what are the latest Rancher enhancements, and talk a little bit about what's coming up in 1.2. Darren, are you there?
Yep, I'm here. Yeah, so right now, the last release of the stable series 1.1 was just to address basically some, you know, HA issues with etcd and Kubernetes, and so we're continuing to make that more and more reliable. So right now there's a lot of work going on the 1.2. We're kind of right in the middle of the development. So we just released the pre-2, pre-3 is coming out today, but in pre-2 we released the Rancher CLI, which is still very much, we're continuing to add more functionality to it, and during the various pre-releases, we may change the arguments and the interface and whatnot as we play with it more and get user feedback. But we haven't released the CLI. I think last meetup or the meetup before was on the CLI. So if you want to go back and look at our YouTube channel, and you'll see a video there. Basically, you can do pretty close to everything from the UI you can do from the CLI. It's a pretty powerful feature. So also, we've added the initial support for Compose v2, which is basically just using the new format, which puts basically all the services under the service key. But the big thing that people are asking for volumes and networks is not coming until a little bit later in the 1.2 development lifecycle. Like 1.2, we're looking at really releasing that, I think, like end of October. But you'll see over the coming pre-releases, there'll be more support for the volumes and networks. It's all aligning with a lot of work that we're doing in 1.2, which is like the focus of 1.2 is really around expanding the infrastructure management capabilities of Rancher, such that you can pick different storage and networking frameworks. Like we've always shipped our built-in networking, and there's been a little bit of pluggability with storage through external templates through the catalog for storage. But we're greatly enhancing that. We're adding better support for CNI, like even CNI for Docker and CNI for Kubernetes, and then more work for like full management of volumes and whatnot for storage. So a lot of that is coming in the 1.2. So we kind of held back on pushing the Compose v2 support for storage and networking because we want to get all the backend in line. And the last thing there is the catalog now supports branching. Basically what that means is before you could always give it a Git URL. That's where the catalog is stored, is just a Git, and it always just pulled the master branch. And now when you configure URL for Git, you can just say, I want it on the dev branch or the QA branch or something like that. And so this greatly helps with kind of like your workflow of people can put in PRs to different branches. You can test those PRs, and then if that's good, then you can merge the branch to like your production branch and push that out there. So those are the enhancements we've done, and really in 1.2 we've got a lot of stuff coming. There's a lot of work been going on under the hood to make Rancher much better.
Great, thanks Darren for that update. So I know there are probably some questions that we didn't get a chance to either answer in the meetup or through the chat. I tried my best to keep up with the influx of questions, but if you have further ones, feel free to either find us on GitHub. We have forums at forums.rancher.com. You can find us on Twitter. Anywhere you can go to ask questions, feel free. We try our best to answer as much as we can. And then thank you everyone for joining. Thank you especially to Alena for demoing Kubernetes and Damien from Nuxeo. It's been great having everyone here, and we will see you next month at next month's meetup. Thanks everyone.